Welcome, second graders, to the Dallas Independent School District STEM Environmental Education Center. And we'd like to give a special welcome to the schools who are with us live this afternoon. We have Arthur Kramer, Arcadia Park, Rosemont, and Walnut Hill with us. Thank you so much for joining us today. We wish you could be here in person, but since you can't be, we're going to do our best to make you feel like you're here during a virtual field trip experience. If you are watching this and have not registered for this field trip yet, you can still do that by going to www.tiny.cc/pk-2 registration. Once you get to that site, you can register yourself or your class for this field trip. And we just use that information for our attendance purposes. This afternoon's field trip is going to be all about matter and energy. During this virtual field trip, students will observe and classify matter by physical properties. Students will compare changes in materials caused by heating and cooling. Students will also observe that things can be done to materials to change their physical properties. So we're going to start things off this afternoon by exploring relative temperature with Ms. Schramm. Then we're going to look at the physical properties of texture and flexibility with Mr. Ramirez. Next, we're going to explore how heating and cooling can change materials with Mr. Dominguez. And last but not least, we're going to look at how cutting, folding, and sanding can change materials with Mr. Monroe. While we're doing all of that, you can ask us questions, and we encourage you to ask questions. Since this is a virtual field trip, the way you ask a question is you go to www.tiny.cc/question-answer. And once you get there, you can submit a super short form to ask us any questions you have related to matter and energy. You can ask as many questions as you like, and we'll do our best to answer all of them in the time that we have with you this afternoon. So I'm going to turn things over now to Ms. Schramm, who's going to get us started with relative temperature.
Hi, everybody. It's me, Ms. Schramm. We are talking about relative temperature today. And let me get this popped up. Oh, sorry, guys. Okay. So at the end of my section, you should be able to classify matter by relative temperature. So before we get started, we need to talk about what is temperature. Temperature is a measurement of heat. So the higher the temperature is, the hotter something is. The lower the temperature is, the colder something is. And we can use temperature to describe the weather and objects as well. But how do we measure temperature? Well, when you are entering the school building today, you might have seen one of these thermometers. This thermometer is an infrared thermometer. So it shines a beam onto your face, and then the results come up and it tells you what your temperature is. The reason is we want to know if you're feeling sick, if you might have a fever. This way, whoever's at your school or maybe the nurse can use this infrared thermometer to see if you have a fever. All right. Another type of thermometer is a classroom thermometer. This kind you'll probably see in your classroom, maybe sometimes outside in a garden. It has two different sets of numbers you might notice. So on the left, it has a letter F, and the numbers are much bigger. That F stands for Fahrenheit. So in the United States, we use Fahrenheit to describe temperature. And so when you hear on the weather that it might be 75 degrees or 80 degrees, they're talking about degrees Fahrenheit. Degrees is the unit of measurement for heat. So on the other side is Celsius. So other countries around the world, or sometimes in a science lab, will typically use Celsius, which is just a different unit. It's kind of like inches and centimeters. All right. Next, you might see this in the kitchen. This thermometer tells you how hot you need to cook certain meats. So different meat you might cook has to reach a certain temperature for it to be safe to eat, to kill off any yucky bacteria or to make sure it's fully cooked. So usually you'll see this type of thermometer in the kitchen. And the last kind of like the first kind, this thermometer goes right under your tongue. You might see it at the nurse, at home, or at the doctor. That kind tells your body temperature. So you stick it under your tongue, you wait for it to beep, and it pops out a number telling you how warm your body is. All right, reading a thermometer. We're going to talk about reading a classroom thermometer. So if you look, right now we only have Fahrenheit because that's what we mostly hear in second grade. So we're going to look at the center and you see a tall red line. That red line represents a liquid inside the thermometer. Now, traditionally, old-fashioned thermometers were made using a liquid called mercury. Now, when mercury would heat up, the liquid would expand. So as it got hotter, the liquid would expand, raising up and filling the tiny little tube at the middle of your thermometer. So the hotter it got, the higher it went. And conversely, when it gets colder, mercury would contract. It would get smaller and shrink down. So the number would be lower. All right, so let's try to read this one. Now it's a little blurry, but I still zoomed in. So we can see that that red line almost lines up with the 60. So that thermometer is reading 60 degrees Fahrenheit. Let's try another one. This thermometer, we've got to zoom in close because I don't see a big number right next to that red line. So let's see. That red line is past the 30, but it's not quite at the 40. So if I'm skip counting, I know these numbers are skip counting by 10. We got 10, 20, 30, 40. But that red line is halfway between. Well, if I'm skip counting by tens and it's halfway between, that's probably going to be 5. So 30, 35, then 40. So I know that that red line is about at 35. So that thermometer is telling me it is 35 degrees Fahrenheit. How can we describe temperature? So we know how to measure temperature using a thermometer. How can we describe it? So this is like when you're listening to the weather and they tell you how cold it's going to be or how warm it's going to be. This is how you can describe the weather. So if it is 30 degrees, that is freezing. You are going to be freezing cold. You're going to want to put a winter jacket on and a coat and hat and gloves, the whole bit. Freezing. Next, we have a thermometer that's telling us it's 40 degrees. You might still want to wear your coat, your hat, your jacket, all of that stuff because it is cold out. Next is 60 degrees. It's cool. Maybe in the fall or the spring, you want to grab your jacket. You'll probably want to wear long pants. It's cool out, but you won't be freezing cold anymore. Next one is 80 degrees. That's when you want to put your shorts on and your t-shirts and go outside and play. It is warm. And last, I know we've had a bunch of days like this when they are over 100 degrees. It is hot. You'll probably just want to put your suit on and go swimming. All right, more temperature and the weather. Just for example, the average temperature for Dallas in September, so this month, is 89 degrees Fahrenheit. That is warm heading to hot. So typically here in Dallas, Texas, it is warm all through September. Last year, I got these numbers that were recorded from the DFW airport. The hottest temperature they recorded last year for 2020 was 106 degrees Fahrenheit. That is really hot. If you look at that thermometer, it's almost filling it all the way to the top. On the other hand, last year when we had that horrible winter freeze, or last winter, I mean, the coldest recorded temperature at DFW airport was 4 degrees Fahrenheit. That's well below freezing. You remember all those pipes were freezing and we were freezing, and that was a record-breaking cold. All right, so temperature in the kitchen. When you are eating or cooking, you might experience a lot of different temperatures. When you eat ice cream, that is freezing. When you have popsicles, that is also freezing. You keep them in the freezer, and if you eat them too fast, they'll cool you down too and give you a brain freeze. So those are freezing. If it's been a hot day, you might go inside and have an ice cold glass of lemonade, or you might have a cold glass of milk. Now, chips and apples and other snacks that you might keep in the pantry or on the counter, those I would say are cool. You don't keep them in the refrigerator, and you also don't have to heat them up. They're just cool, like room temperature. If it's chilly out as we lead into fall, you might want to have a warm bowl of soup. Or in the morning, you might want some warm toast. And if your toast isn't warm enough, it's not going to melt that butter. Then, I know I love pizza. I have pizza way too often. But sometimes when you take that pizza right out of the oven, it is hot. It's so hot, you could burn your mouth. And another one of my favorites that I have all too often, and your teachers do too, is hot coffee. Sometimes if you don't let that coffee sit for a minute, it's going to be so hot, it's going to burn your mouth. All right. So before we do our closing questions, I wanted to go over some temperatures of some beakers I have in my room. So I have the first one, this glass of water I've had sitting out in my classroom for a little while. So it should be the same temperature as the air. So if I pull my thermometer up, you won't be able to see it, but trust me, it is about 70 degrees Fahrenheit, which makes sense because I have the air conditioning on. It's cool in here. Now, if I take a glass of ice, it won't be exactly freezing because it's been sitting out for a few minutes, but it is about 32 degrees Fahrenheit. That is pretty cold. Then, my favorite example that I would love to drink right about now is my fresh pot of coffee. And oh my goodness, it is about 120 degrees Fahrenheit. That is hot. So maybe I'll let it sit for a minute. All right, so my closing questions for you before I send you off is, what tool is used to measure temperature? And what words can we use to describe temperature? All right, thank you. Have a great rest of your field trip.
Thank you, Ms. Schramm. We got a number of questions that came in. Marianne asked, what state of matter is fire? Fire is not a state of matter. It is a form of thermal energy. And then Jack asked, Oliver asked, what is the fourth state of matter? And that is plasma. And then Jack asked, what is plasma made out of? And it is made out of matter, or you could say superheated gases. So maybe on the sun, the fire would be a plasma, but on Earth, it's not hot enough to be considered plasma. It's just a form of energy. Bradley and Victoria Lynn asked, how does matter take up space? Matter is made up of particles that take up space, so it takes up space. Thiago asked, what are clouds made out of? They are made out of condensed water droplets that are still light enough to float in the air. And Anton asked, how does an infrared thermometer know your temperature? When that laser is pointed at you, you are giving off heat, and so it can tell what your temperature is by comparing your temperature to the surrounding temperatures around. All right, now we are going to look at flexibility and texture with Ms. Ramirez.
Hello, my name is Ms. Ramirez, and to help us learn about texture and flexibility, I have an animal friend that I'm going to show you because she demonstrates both. So listen to my clues to who this animal might be, and then I'll bring her out for you. So she has no legs. That should be your easiest clue. She has a scaly but yet smooth texture when you touch her with your hands, and she's also super flexible. And she's a carnivore. So think about what animal you think this is, and I'll go pull her out. So be making your guesses. Tell your friend beside you who you think it is. And if you guys guessed a snake, you would be correct. So this is Pelota. She's a ball python snake. And they get that name ball python because when they are scared, they can curl into a tight ball. So she is super flexible. She does have bones, so she is a vertebrate just like us, but she is rather flexible. She can get into some super tight and small places. She also has that scaly texture to her, and she's also kind of smooth. So oftentimes kids think that these snakes are rough, but she's actually rather smooth if you were to touch her. So I'm gonna go ahead and put Pelota, the ball python, up, and we'll continue on with our presentation. Now, when I said she was a carnivore, that just means that she only eats meat. So she gets fed things like mice. So I'm gonna go ahead and share my screen with you guys, and we'll take a look at some other examples. So hopefully by the end of this presentation, you'll be able to answer these two questions. The first is, which sense or senses can you use to observe the property of texture and flexibility? And the second thing is, give two examples of textures. So hopefully by the end, you'll be able to answer those two questions. I also have some cute videos here on the slide. I have a cute dog who's being petted. Think about, how do you think this dog feels when you touch him? So we're thinking about texture words there. And then I also have a little video clip of a snake eating an egg. So the question there is, how does being flexible help the snake? So keep those questions in mind. Teachers, feel free to pause the video to allow students to discuss their answers. But I'm going to go ahead and move right along. So the first thing we're going to talk about is texture. Texture just means, how does something feel when you guys touch it? So we're going to play a little texture game. We have 4 animals on the screen: animal number 1, animals 2, animal 3, and animal 4. I'm going to give you guys some texture words, and you're going to try and guess which animal has that texture. Now, technically, we can use our hands to help us determine texture, but since you guys can't be with us today, we're going to be using our eyes to help us determine texture. So the first texture word I have for you guys is bumpy. So which animal do you think feels bumpy? And hopefully you guys said animal number 1, the toad. And even though you guys can't touch the toad, we can tell he's probably bumpy because if you look at his skin, he has some raised spots or bumps on his skin. My next texture word is smooth, just like our snake, and also moist. Moist just means kind of a little wet. So think about what animal fits that description. And hopefully you guys said it is the frog, number 4. So here's our little frog. And the clue for this one is, if you look at the frog's head, you might see like a little glisten or a shine. That lets us know that that frog probably has a little wetness or moistness to him. Our next word is soft and furry. This one's super easy. So which animal do you think might feel soft and furry? And this is one of my favorite animals. There's actually 2. We have a fluffy brown cat and that dark gray chinchilla. And the chinchillas are super soft. They are probably one of the softest animals you guys will ever touch. I used to have a chinchilla, and he was my best friend and my best pet. So those are our 2 soft and furry animals. And then my last texture word is spiky. So what animal is spiky? Should be super easy. It's the last one we have. Hopefully you guys said animal number 3, and that is a porcupine. So I wouldn't recommend touching a porcupine, but if you had to, he would probably feel rather rough. The ends of those modified hairs would probably feel like pointy or spiky at the edges. So that porcupine is definitely not going to feel like this soft cat over here. So again, texture just means, how does something feel when you touch it? And we can use our senses of touch, and we can also use our eyes. And our next words are flexible and not flexible. So if something is not flexible, we can say that it is rigid. So let's look at some examples. So here we have a flexible piece of metal. It's called a steel ribbon. And because this metal is so flexible, it's often used as a toy. And you can see we have some goats that are running and jumping on it to play with it. So you can see how it flexes and bends. So things that are flexible can be bent rather easily, and it's usually not going to break. We also have a flexible rope toy. So that rope is rather flexible. It's able to be stretched and pulled, and it's not going to break. So think about things like a rubber band or the hair scrunchies that you guys put for your ponytails or your buns. Those are also flexible things. And then we have something here that's not flexible. It's actually rigid, and it's a door. So you can see that poor little dog running straight into that door. The door's not moving. It doesn't have any give, so it's rather rigid. And then here we're gonna look at a quick little video of a super flexible young girl. And again, we can use our senses of touch and sight to help us determine flexibility. So let me play this little video for you guys. I like watching America's Got Talent, and this was a girl that was on that show. And you can see just how flexible she is. Now, oftentimes people like dancers, yoga instructors, athletes, those are usually going to be your super flexible people. They're using their flexibility to their advantage for a career. In just a little bit, we're going to see just how flexible you are. Now, we're not going to do anything crazy like she's doing, but we are going to do some simple flexibility tests. Obviously, I wouldn't recommend trying any of these things at home, but I thought that was rather interesting for flexibility of people. So in our next slide, we are going to take a look at how flexible are you. So we're going to do 3 flexibility poses. We're going to do this first one here, where we're just going to stand up and touch the ground. We're going to do the second one here, where we're just going to try and put our hands behind our back and make like a triangle with our fingertips. And the last one, we're going to sit down and try and touch our feet. So here's our little video. You can follow along if you would like, and you can see who is the most flexible in your class. Now I'll let you know I'm not the most flexible, so y'all are probably better than me. So here's our video. Arms in the front, arms up high. Put your arms back in the front and then put to your side nice and wide. Then you're going to slowly bend down and touch the ground with your fingertips, and then try and touch the ground with your hands flat on the ground. Now, if you can touch with your hands flat on the ground, you are very flexible. And then you can take a moment to stand up, put your hands out to your side, put your hands behind your back with your fingers touching and pointed down, and then try to turn your fingers upwards, like you're pointing up. So you can take a look at how I'm standing there. Then the next one, I'm gonna have you guys sit on the floor. So go ahead and find a spot on the floor. Once you have your spot on the floor, all we're gonna do is sit down, and then you're gonna take your arms and you're gonna reach all the way as far as you can. If you can touch your feet, great, but if you can go past your feet, then that means you're really flexible. So go ahead and make sure you're sitting down on the floor. This is called the sit and reach. So I can at least touch my feet. I can't go that far past my feet, but the further past your feet you can go, the more flexible you are. And that is super important because as you guys get older, you start to lose your flexibility. So that's why it's important. We had a previous teacher who loved to do yoga. So yoga actually helps as you age. It keeps your joints nice and healthy. So our next thing that we're going to do is I have a nature scavenger hunt for you guys. I would like for you guys to go outside and find 5 nature items, describe their texture. So how do they feel when you touch them? Sort those items into 2 groups, flexible and not flexible. And then here I just have some more thinking questions for you guys to think about how flexibility helps these 2 animals. We have the octopus, and then we have the not flexible shell of a mollusk. So I'm going to go ahead and stop my screen share. And before we go, I do have a bird nest. So birds are taking advantage of these flexible twigs to create their nest. And people also take advantage of the flexibility of some twigs to help make things like baskets. So think about how does flexibility or rigid things, how do we use them for our purposes? So that's all I have for you guys today. We're going to give it to Mr. Broughton to answer any questions.
Thank you, Mr. Ramirez. Teddy asked, why do snakes have to eat meat? And snakes have been around for millions of years, like maybe 90 to 100 million years. And over all those years, they have evolved into carnivores, and that's why they have to eat meat today. And Olivia has a kind of a similar question. Her question is, why do some animals have fur and some don't? So animals have been around for thousands of years at least. And over all those years, they have evolved different body coverings to protect them either by camouflage or from the cold. So some animals have fur and some don't now. All right, now we are going to look at heating and cooling and how that can change materials with Mr. Dominguez.
Hi guys, it's Mr. Dominguez here with the EEC, and I'm here to talk to you about heating and cooling and how those two things affect matter. As you guys may have already been told, everything around you is made out of matter, including Kiwi right here, the bearded dragon, your desks, your pencils, everything you can think of is made out of matter. Now, why do I have Kiwi here as my helper today? Well, I wanted to showcase a cold-blooded creature because I think they are very interesting because they rely on the environment to properly regulate their bodily functions. And I'm talking about the heating and cooling elements of the environment. So for example, the sun warms her up and keeps her bodily functions going. And she right now is pretty warm, so that's why she's active. But when she cools down, she slows down. Now, that's one example of how heating and cooling affects something made out of matter. Now, I'm not going to be using Kiwi here for my demonstration today because I'm going to be using a little bit of fire to help you understand how heating and cooling affects the properties of matter, but only with abiotic things. Abiotic means non-living things. Now, Kiwi's biotic, which means that she's a living thing, and we're not going to subject her to any experiments today. Right, Kiwi? She wouldn't like that. So, wave bye to Kiwi, guys, and I'll be right back. Before we begin our experiment, let's review the different states of matter. There are solids, liquids, and gases. And while the examples before you have different physical properties, it's all water. So how did we get from a hard, blocky solid to a wet, clear liquid to a invisible light gas? Antes de comenzar nuestro experimento, repasemos los diferentes estados de la materia. Hay sólidos, líquidos y gases. Y aunque los ejemplos anteriores tienen diferentes propiedades físicas, todo es agua. Entonces, ¿cómo pasamos de un sólido, duro, en bloques, a un líquido transparente, a un gas invisible? Maybe some of you spotted the clues. One of the ways we can change the physical properties of matter is by heating and cooling. Tal vez algunos de ustedes vieron las pistas. Una de las formas en que podemos cambiar las propiedades físicas de la materia es calentando y enfriando. So, I have my thermometer here. This was the big clue. And as you can see, I've already started to heat up some water, some liquid water, and some solid water or ice cubes. And as you can see, we already have a little bit of change. So I have some solid water melting into liquid water. Now, this just started to heat up, but you can see some very small bubbles. So this water will eventually reach its boiling point and it will start bubbling and release gas, or will turn into gas. Now, we don't want to be here forever, So I'm gonna speed this up. All right, guys, so to speed things up, I came to my microwave, one of the best tools that you have in your own home to heat things up. And as you can see, we see a liquid turning into a gas simply by heating it. So I'm going to open this microwave door up so you can get a better view of what's happening. So, you guys see all that gas? I do. So we went from a liquid to a gas. All right, guys, so now that we've seen what happens when we heat up matter, how the properties change, how we go from a solid to a liquid to a gas simply by heating up the matter, I want you guys to ask yourselves, how do we go backwards? How do we go from a gas to a liquid and then to a solid? Quiero que se pregunten algo. ¿Cómo podemos convertir a un gas, a un líquido y a un sólido? You guessed it. We have to cool things down. I want you guys to picture this. I want you guys to think about a cold can of soda. So I have a can of Diet Coke right here. And I want you guys to think of what happens when a really cold can of soda is sitting out in this Texas heat. Well, suddenly you have liquid, little droplets of water forming outside of the can. And it's not the liquid inside of the can that's leaking out. It's actually the water vapor around us that is turning back into a liquid. And you can actually see this right now. You can actually see this. Do you guys see this? You guys see a little bit of, here, I'm gonna run my finger through this can of soda. Maybe you guys can see that. You guys see that? There's some water droplets already forming on the outside. And that's not the liquid inside. That's actually the water vapor cooling down and turning back into a liquid. You guys see that? I put a little smiley face right there. Let's see if I can draw a smiley face. That's all liquid right there. And if we were to take that liquid, if we were to gather it, we were to gather it and put it in a container and freeze it, cool it down a lot, you'd get a solid. So next time you guys pop open a can of soda and you guys see that happening, those water droplets forming in your on your soda, think about how heating and cooling affect matter. I hope you guys enjoyed this portion of your field trip. I will see you guys next time.
Thank you to Mr. Dominguez. Alyssa asked, how can snakes eat an egg? A snake's mouth is very flexible, so they can open their mouth very wide to swallow an egg whole. Kaitis asks, can ice melt fast? Yes, it can if you add a lot of heat to it. Austin asks, do lizards eat worms? Yes, they do. We have lizards that eat mealworms and superworms here, and maybe in an upcoming field trip, you'll get to see that. Rasenemi asked, how do you make soil? Rocks break down over time through the process of weathering, and then dead plant and animal matter decompose and mix with those broken off pieces of rock, and that forms soil. Eleanor asked, what is water made out of? You may have heard water be referred to as H2O because it has 2 hydrogen atoms and 1 oxygen atom. So that's what it's made out of. And Alyssa, how long is a gecko's tongue? I'm gonna have to get back to you on that because I do not know exactly how long a gecko's tongue is right at the moment. But maybe after Mr. Monroe explains how matter can be changed by folding, cutting, and sanding, I will know that. So take it away, Mr. Monroe.
Good afternoon, students. My name is Mr. Monroe, and we're going to be looking into material changing, the properties of matter changing through some processes that we call cutting, folding, and sanding. Well, I'm going to kind of change the order a little bit because I have a very special guest with me today. And we're going to use that guest in talking about the process of cutting. So I'm going to start out with folding. You know, you heard Ms. Ramirez talk about matter that is flexible and matter that is rigid. Well, to do some folding, the matter that is we're going to be using that process with has to be flexible. And primarily, I'm talking about maybe construction paper or just a regular sheet of paper. Now, I can remember when I was a second grader, boy, there was something that all the guys, all the young men, they wanted to do. We were busy when we thought we were bored. We would start making paper airplanes, gliders. And that process of making that little airplane, that glider, involved the process of folding. Now, I approached my supervisor yesterday morning and I asked him if he remembered how to make a glider out of a sheet of construction paper. Because you know what? I hadn't done it in so long, I have forgot how to do that. Well, I'll tell you what, he took a sheet of paper just like this, same color, same everything. And he started folding. I mean, he made several folds. And I was trying to remember each fold that he made, but he came out with a design that looked just like this. Now, in this process of folding, of course, the paper stayed the same, right? The material or the matter did not change. But what did change because of the folding was the fact that the size changed and the shape changed. And you know what? I came up with my own design. Now, remember what Mr. Barton's looked like? Boy, that's pretty sharp. This is my design. It was a very simple design, although it did resemble some type of glider. Now we're going to run a little test to see which one flies better, okay? And you guys may want to do this as a project back there at your classroom. Be very careful if the teacher lets you start testing these, that nobody is in the way of maybe getting hit by them or maybe getting poked in the eye, okay? So let's try this one out. Boy, that was a flash. That thing went by so quick and it flew way over to the other side of the room. Let's see what happens with mine. Ready? Well, mine didn't go as far as Mr. Barton's, but mine did a little weaving and finally went down right there. So folding, did the paper change? No, it continued to be paper, but what was affected was the size and the shape of that sheet of paper. So that's what folding involves in. Now, listen, guys, I want you to remember two things. These processes that we're using, cutting, folding, and sanding, I want you to remember how it affected the matter when that process was done. How the cutting changed the matter, how the folding changed the matter, and we just saw that. It just changed the size and the shape, right? Now, let's go to the next one, and that is sanding. You know, when we talk about sanding, we're talking about using something that has the ability to be abrasive or be able to rub across something and cause it to change. Primarily, we're talking about something called sandpaper. It's got a lot of grit on it, like pieces of sand that are actually embedded in the sheet of paper. And you could, of course, use a sheet by itself, but the sanding that I've done in the past, I've always had to make or wrap it around something to where I can use it, being able to hold it. Now, I had a project that I worked on this summer. It seemed like we didn't have enough canoe paddles for everybody that was in the canoes to at least have 2 paddles per canoe, a front and a back paddler. And so we were one short, and it was a little late to go out and try to buy one when we found out that we were missing one. So I tried to hand make one. And I started out with a plank of wood that looked like this. It was just a wide plank of wood. So that meant that I was going to need to change the shape and the size of the wood, and maybe even the texture. So it involved cutting and sanding. And I started out by cutting it, and I ended up with a canoe paddle that looked like this. Made an excellent paddle, but there was a lot involved. Now, remember what Mr. Ramirez said about something being flexible and something being rigid? Wood is rigid. It's not going to fold. It's not going to bend. It has no flexibility to it, maybe just a little bit, but not very much. So I started out by cutting, and when we're using a tool to cut something as rigid, most of the time we will use a saw, right? Well, the type of saw that I was using was a battery operated saw associated with what we call a reciprocal saw. And that's what I used to cut the shape of the pattern. Now, what happened with the next thing that happened was the fact that students that were canoeing would have to use their hands to hold the canoe paddle just like this. One hand up high, one hand low. And they would have to go through a pulling action if they wanted to go forward. Well, I wanted to keep them safe because remember, the wood was very rough and it had opportunities for students to get splinters in the area where they were holding. So basically I took the sandpaper, and let me share this. Anytime that you're going to do sanding, and I almost messed up, my glasses still protected me. Anytime you're going to do some cutting or sanding, you want to be safe. So you're going to put a safety pair on or some goggles. And here is the sanding. And what it did, it changed the texture of the wood. Instead of it being rough where they might get splinters, it made it very smooth where there were no pieces that could be splinters to get into the students' hands as they were patterned. So that worked out pretty good. Now, listen, there are other things that we do cutting on, not just necessarily paper. Like if paper were cutting paper, we would use a pair of scissors, right? As a tool, not a saw. And if I cut here, this is still paper, right? Now what I have done, I've cut it in half, and it has actually changed the size of the paper. I've got two pieces instead of one. Can I change the shape? Sure. Let's say that I want to cut off a piece of this paper. I cut off a piece that looks like this, and I've actually changed the size and the shape, and I now have a triangle. Now, other material that can be cut is food. We do a lot of cutting of food, making sandwiches, salads, whatever. But you know, out here at the Environmental Ed Center, right at the front of the property before you get to the Post Oak Preserve, there are some fruit trees. And on a couple of those fruit trees, there are pears. You know, when a person is eating a pear, they would maybe take a big bite, right? But in my old age, I found out it's better to cut the pear into smaller pieces so that they can easily be consumed, just like somebody cutting an apple, even peeling it. So I've got my knife, and I'm going to cut a little piece of that pear, and let's test it out. Really a good pear, guys. Is it still a pear? Yes. Did it change size? Yes. Did it change its shape? Me cutting it? Yes, it did. Now, I did that to let you know that we have animals in nature out here that you might observe when coming out, especially this fellow that I have in my classroom that I'm going to get out in a minute. He doesn't have teeth. So whatever he eats, this guy will eat anything he can get in his mouth. And what has to happen, he doesn't have teeth, but the edges of his jaws are knife sharp. So he chomps down and he slices it. He cuts it into smaller pieces so he can swallow it, those pieces whole. Let me get him out. His name is Snappy. There's old Snappy. Boy, he's a big one, isn't he? Boy, this guy will eat anything he can get. Watch. Whoa. And he's got knife sharp edges on his jaws. And if he's not careful, whoa, give me that. Let go of that. Okay. Now, listen, I gotta go. I'm running out of time. So hopefully you understand that cutting, folding, and sanding changes material or changes matter in shape, size, and texture. You guys have a good day the rest of the day. And if there are any questions, I bet Mr. Broughton can answer those questions for you.
Thank you, Mr. Monroe. Getting back to that, how long is a gecko's tongue question? It's difficult to say because some geckos are only like 1.6 centimeters long, the smallest ones, like the width of my pinky, but some are longer than this whole ruler when they're fully grown. So it just depend on the size of the gecko as far as their tongue, but they do have a longer tongue than other animals have, like us. We don't have a very long tongue for our body size. Roman asks, what do snakes eat? Snakes are carnivores, so they eat meat, mostly small animals and eggs. And Harlem asks, how do clouds form? Clouds form when water vapor condenses up in the sky as it cools to form little water droplets that form clouds. And I'm going to share my screen and do a quick recap of what we did today. So again, this field trip was all about matter and energy. We started off by exploring relative temperature with Ms. Schramm using a thermometer. Then we explored texture and flexibility with Mr. Ramirez. Next, we looked at how heating and cooling can change matter with Mr. Dominguez. And then we just saw how cutting, folding, and sanding can also change matter with Mr. Monroe. Thank you so much for joining us this afternoon. We appreciate you taking the time to learn about matter and energy with us. We hope you enjoyed this virtual field trip, and you can let us know whether you did or not by going to www.tiny.cc/pk-2 feedback and filling out a short feedback form. We hope to see you again in about 3 weeks for our next field trip for second graders. Have a great rest of your day, and we'll see you next time.